Hello, I will talk today about a referred case that we discussed to submit it for final assessment for the course of clinical bioinformatics. This referred case is for a female patient which has been diagnosed with Usher syndrome, suspected to have Usher syndrome because her ankle also has Usher syndrome, but he has homozygous allele. When they are trying to find this allele, they found only one allele mutation in the patient. So I just give you a brief introduction about Usher syndrome. It's a rare genetic disorder and it's caused by autosomal recessive gene. The primary feature for Usher syndrome usually is deafness or retinal pigmentosa, which make loss of vision. Types of Usher syndrome, there are three types of Usher syndrome. The first type, which is profound hearing loss, usually become at birth, and also the balance problem start as well in childhood. Vision problems start at 10 years old or early teens. For Usher syndrome type 2, it's moderate to severe hearing loss, and also they are suffering from night blindness, which occur in late 20s. The loss of vision usually become a loss of peripheral vision, not on the central vision, and that loss of vision usually progresses slower than other type of Usher syndrome. The third type of Usher syndrome, it's a later onset hearing loss, which occur in 30 or 40 years old, and also they have late variable balance dysfunction. Not all of them, around 50% of these patients, they do have this late variable balance dysfunction. The genetic mutation for Usher syndrome, there are around 12 genes have been reported associated with Usher syndrome. Like this is how we saw in the literature review, and we're gonna talk about some of them. Referred data, we have that data comes from the instructor, which is comes from like a sequencing for blood sample, the sequence for retinal dystrophy panel, and the format that we got the file for in a fast QSanger format. And we are today going to analyze this data using Galaxy website. Very brief, just to show you how we are doing this pipeline to analyze the data. We have this data and we check for the quality, and then trying to improve the quality using a trimming task, and then we're going to align it. For sure, we have to check the quality as well, and then we align it. And then we are trying to remove the duplicate from the aligned sequence. And then we're going to do a variant call. This variant calls will generate a VCF file, and we download this VCF file, and then we can upload it in different websites, which is Variant Effect Predictor. We're gonna analyze this variant in Variant Effect Predictor using several filtration process, and then we're going for the classification of process and check in the phenotype in Alman database. Then we generate the report. The Galaxy website, we usually, when you have the account and you log in, you're gonna see several tools over here on the left side, and you can just fill up this form. And then when you finish that job, you're gonna see this file colored with the green. You can check the file anytime by clicking on View File. So the data we got as fast QSanger, so we check the file, the quality of the file. Actually, the quality of the file is pretty good quality. As you see here, the first score is more than 30. And the length is 150 per sequence. And if you would like to know more about that quality, you can just click each one to see the graph, the histogram graph for each category. and then you can decide about your equality. For our file, we think we have really good equality sequence. Although we have good equality, but we can just put an additional process with the trimming process. And I put it Thermomatic. I used Thermomatic under QC and manipulation. This is a tool just to clean up the file from low quality reads. Like when you are trying to do the trimming, you can choose which trimming task that you would like. I use here the sliding window trimming, or you can choose taking out the end read, or you can just drop reads below a specific length or a specific threshold. For me, I just use the sliding window here, and I use also min lane, which is drop reads below 60, the read 60. And then we can check the quality again using FastQC read quality report, and we check the quality. We see the quality is it's good quality of sequence. We do the data alignment. After that, data alignment usually we use. There are several tools to do the data alignment. One of them is map with PWA and MEM. We use that one for long read. We just put the reference genome which is the file, and then you can just keep the default choice and press execute. Then you're gonna get BAM file. After you generate BAM file, it's good to remove the duplicate that has been generated through PCR process. We can do this using SAM tools. And this is like under the SAM tools, you can see RAMDOP, which is removing duplication. It's very basic and simple way. You just put your aligned file here, and then you can just keep that it's BAM paired file, and then execute the job. So it will the file will be generated, going to be filtered BAM file. So you're going to use this filter BAM file all the time after this. To check the quality after the filtration, you can go for different tools, which is called the B-card tools, and you can go for collect history matrices. When you go there, you choose the filter BAM file, and you can see a table with different category, and you can see the total read that you have, and how many read has been aligned, how many reads has been dropped. And we think we have really a good aligned file here after we got after we have this matrices. The next step is variant call. We use a free base variant call, which is under variant analysis tab. It's a pretty simple way as well to do the variant call. We just need to decide about the reference genome. And we put the reference genome HHG38, and also you can just put the parameter for selection. I put here symbol diploid calling. Then the file of VCF file will be generated. You can click view to see this file, the VCF file. Also, you can download it, which is would be easier for you to proceed with the next step. So after we download this file in our local computer, we are going to use this file on a different website, which is Ensemble Variant Effective Predictor. This is the link for it. You can upload this file from here, choose file, and then you start to use the database, the reference database. Use here RefSeq database, or you can use whatever database you would like. And also you can put additional categories or additional configuration for this variant. If you would like to know more information about this variant, such as the prediction tool or the allele frequency, or even details about the variant and the nomenclature. So after I upload it and I run the job, I got all these type of variant. I try to do some kind of filtration to make sure that whatever we have, it's linked to the patient. First, we do apply filter from here. So first, I do the consequence variant using missense consequence, and then I put impact variant, which is either moderate or high impact. Usually, you can decide about your filtration from the first time you see the file. And then I go to biotype because we would like to have a protein coding, and we filter for only existing exome. So when we reach this point, still we have several variant, and I would like to see the variant related to Usher syndrome. So I went to Biomart here, this click, and I click gene here, and I listed all the genes that we presented earlier, which is we know it's associated to Usher syndrome. And what I got a list of genes that related to Usher syndrome, but I tried to find out if there is any clinical significance, but unfortunately all of them either benign or likely benign, and I didn't see any pathogenic or likely pathogenic variant. So then I did my second filtration, which is going for the clinical significance to see if there is another variant, pathogenic or likely pathogenic. And I got one variant over here, which is BBS10 gene. To make sure that these genes have a classification as pathogenic or likely pathogenic, I went to ClinVar, and I saw that this genes has one submission says pathogenic, no assertion criteria providing. But I go search more for this variant in the SIFT and polyphen just to use it as a prediction tool. We saw that this variant has been reported as deleterious by SIFT and probably damaging by polyphen, which give me like a kind of hints to go and search more in different database. So I went to other database, which is Varsome. They're using this website. They're using several database to decide about the final classification, and I got the likely pathogenic classification here. And this is based on several criteria here, if you see here, and based on the allele frequency and also about the report of this gene. As you see here, is it 19 out of 26 of non-VOS missense. Usually it's pathogenic, and this is how they consider if there is more than a threshold has been reported as pathogenic. And also other criteria as well, and they are considering all the criteria and the database and a prediction tool. And then we got the like pathogenic. So at the end, I got this variant, BBS10 gene, which is homozygous and autosomal recessive. It's missense variant, and we have the final classification as likely pathogenic, and the protein encoded for this gene is Bardet-Biedl syndrome 10 protein. I searched more for this syndrome, Bardet-Biedl syndrome gene, and I checked that and I tried to link it with the phenotype for the patient, and I saw that 46% of the mutation in BBS10 gene can cause retina pigmentosa, and this is give me a clear indication that could be the cause for the patient case. So Bardet-Biedl syndrome, it's usually they have a kind of primary features like progressive vision loss and some other vision, which is extra finger and renal problems, opacity, hypogonadism. But the renal, the progressive vision loss usually start with a spot, like blind spot in peripheral vision, and then this blind spot become bigger and bigger, and until the patient like lose the vision. At the end, I make the report based on everything that I found in my analysis about the result and the variant, and then the result of interpretation. And also we put the test methodology and also the recommendation as well at the end to look at different features for Bardet-Biedl in the patient. Thank you very much.